Welcome back to another video, and in today's topic we'll be talking about combining functions. Now, from the previous videos that we talked about functions and intervals, and also the different types of functions that we have, like squaring functions and cubic functions, those kinds of functions, we can combine them basically. And how do we actually just like combine everything, right? We all have different rules of combining, just like in the next few years that you're going to be doing like calculus, right? There's a lot of different rules here. So we're going to try to make these rules as simple as possible, and hopefully they shouldn't be any surprise to you because it's mainly just simple operations. So for our first rule, we have something called the sum rule. Now, the sum rule, hence by its name, it's going to be the addition of two different functions, right? So one notation that we use is this, f plus g of x, right? Now, f and g, they're both two different functions that we have here. And by pretending that those are two different functions, we can expand this out by just saying that f of x plus g of x, right? And later on, once you see examples of these, it's going to be a lot easier for you to understand. So let's say, for whatever reason, that as an example, f of x is equal to x squared, and g of x is equal to 2x plus 5, right? So now if I said f plus g of x, right, that's going to be the same thing as f of x plus g of x, and ultimately it just leads to x squared plus 2x plus 5, right? Now that is our complete function based off of what we use on the sum rule. Now, secondly, we also have a difference rule, right? Now the difference rule, it works the same, right? And where it's gonna, instead of plus g, it's gonna be minus g. So f minus g of x equals f of x minus g of x. And then as well as our two other operators, the product and the quotient. So product rule. The product rule is just f times g of x. Equals f of x times g of x. And lastly, we have our quotient rule. Quotient rule is just f over g of x equals f of x over g of x, right? And just for like a message, right? I have never seen these rules pop up before on the Regents. So, but it's still good to keep it in the back of your head, because if for whatever reason they do decide to put it on there and without like us knowing that it's going to be on there, at least you guys know that these are the different rules that they are, right? And everything's clear. So everything's on there for you. So don't make it look so complicated, right? Like let's say the product rule, right? It's just f times g, right? That's it, right? Later on, we're going to see some variant of the product rule, which will indeed make it a little bit more confusing, but the notation is really, really significant to look at. So in this case, for this one, we're going to emphasize that it is a closed circle. Closed circle. We have to emphasize this. It's a closed circle. It's not an open circle. An open circle will be something else. All right. So now let's do an example, right? So based off the rules that you just looked at, as our example, f of x is equal to the square root of x, and g of x is equal to 2x plus 1, right? So we're going to evaluate these expressions based off of these rules that we just figured out. First one is f plus g of 9, right? The second one would be f minus g of 4. Third one, which we're going to do, is f times g of 16. And lastly, we're going to have f divided by g of 1. Alright, so take a moment, pause the video here, see if you guys can figure this out, and we'll get right back to it. Alright, so hopefully you just looked at these problems and tried to solve it out. So let's start solving it. So now, this is just mainly equal to f of 9 plus g of 9, right? So that's going to be equal to the square root of 9 plus 2 times 9 plus 1, and that gives us 22. In this first example that we did, we used the sum rule, right? Where the two functions are added together. So now for the second one, as you might have guessed already, we're going to use the difference rule, where both of the functions are subtracted from each other. So in this case, it would be f of 4 minus g of 4. And that's going to equal to the square root of 4. Now, this is where we got to be careful, because g of x is two terms here. So we have to remember to put the parentheses, right? So we're going to put the parentheses, 2 times 4 plus 1. Alright, so in the last few videos, I've been emphasizing about how to put parentheses, right? Parentheses are a big factor when it comes to doing operations like these. Because if I write the square root of 4 minus 2 times 4 plus 1, that is not the same thing as what we just wrote here. Because g of 4, remember, there's invisible parentheses around this g of 4 whenever there's a negative in the front, right? So that has to be in parentheses because we have to distribute the negative symbol, right? So we have to evaluate what g of x is first, and then we subtract it. So in this case, for the square root of 4 is 2. 2 minus 2 times 4, 8, and then minus a 1. That will give us a negative 7. Right? So that is why I've emphasized that we must use parentheses here, because the common mistake that people make with all of these problems is that they forget to put the parentheses and they forgot to distribute the negative. That has also been a mistake that I've done countless amount of times. So make sure that you put the parentheses there and make sure that you distribute the negative symbol, right? Now for the next one, we're going to use the product rule here. So f of 16 times g of 16, right? So that's just equal to the square root of 16 times 2 times 16 plus the 1. Now, we have to put the parentheses there. Remember, I almost forgot to put the parentheses there, but we have to, okay? That is equal to 4 times 2 times 16, 32 plus 33 times the 4, so that's 132. Alright? That's 132. Now, for our last one, we have the quotient rule, right? So it's going to be f of 1 over g of 1, which is going to be equal to, f of 1 is just the square root of 1 over 2 times 1 plus 1. And that's just going to be equal to 1/3 here. So there we go. Now, these are the answers to the functions that we just combined. And yeah, that's how we do it. Now, what if I just told you, hey, what if we added coefficients to these things, right? well, it makes it a little bit more complicated, but it's not that really, right? So you might have seen like, oh, 2 times f of x, right? Or 3 times g of x, right? Now, this is the thing. So let's say if we have the sum rule here, right? Let's apply it to sum rule. We can do 2f plus 3g, right, of x, right? That is just the same thing as 2 times f of x, right? Plus the 3 times g of x, right? That is basically just the same thing here. There's nothing special about it. It's just that we're taking the respective coefficients. So in this case, the reason why we put the 2 at the f of x, right, is because the 2 in the beginning is for the f of x. So it's only multiplying the f of x. Now the 3 here is only multiplying the g of x, right? Now it would work differently if it was like 2 times f plus g of x, right? Then that would be worked differently. Then that would just be equals to 2 times f of x plus g of x, right? That works a little bit differently though, because the coefficient is outside of this whole entire operation here, right? This whole entire operation. So that's why we had to only distribute the 2 to the f and then the 3 to the g, because those are respective to each other, right? So it's the same thing with the other rules, right? Where you have like the difference rule, the product rule, the quotient rule. Just make sure that you like look at the symbols clearly, because some people they look at the symbols and then they mess up because they see something that they're not familiarized with. And for your information, I have never seen this on any testing so far. So it's it's a slight chance that they might add it, but I don't really know if they will. So just keep this in the back of your head to remember. Now, our next topic is something that's going to be a little bit more complicated in a way. So, we have something called composite functions. Now, composite functions is something that almost everyone messes up on, right? I didn't I didn't understand it until like a year after. So, I know from experience that it's something that's complicated, right? So, for this part, you have to really pay attention to, because it's going to go by really quick and there's a lot of information here. So composite functions. Composite functions. So composite functions, right? The way how we write them, right, is like this. Let's say f of x is a function and g of x is a function, right? So then it's going to be f o g of x. And or, well, this is where we get most of the part. So you see how the f is first, right? Since the f is first, we're gonna put the f on the outside, f, right? Now we're gonna treat it as like, oh, it's about to start a function, right? We're about to like input the whatever the input is, right? And you see how g is second, right? So then we keep the f parentheses like that, and we just write a g of x. And then at the end, we just close the f of x, right? So that's how it works. We just split it up. So let me restate it again. Since f is first, right? F is first, then it goes first here. Now, since g is second, right? G is second. That means that over here, g is the input for f. If that makes sense. Right? Because whenever we have composite functions, there's always going to be an inner function, and there's always going to be an outer function. So that's how we split this notation up. So let's say for whatever reason we just switch the variables around, right? So let's say if it was g of right, of x, then since g is first, right? G is first, we're gonna write g here first, the parentheses, right? But f is second, so we're just gonna write f of x here and close the parentheses. That's how simple it is. So remember, whatever comes first, right? Like let's say if f comes first, okay, then f is the outer function. If g comes first, g is the outer function. But whatever comes second is always going to be the inner function. And it's always going to be embedded inside of the outer function, just like what we've shown here, where g is on the outside and f of x is on the inside, right? Now, how do we actually like read this, right? So the way how we read this, let's use the first one as an example. We would read this as f of g of x. So it's a little bit long. It's similar to how we would say like f of x, right? We're just saying that in the function f, there's an input named x, right? But in this case, since we have two inputs, where f also has an input, but then g also have an input, we have to say f of g of x. So think about how would you say this second one here, right? It's gonna work the same way. So you might have guessed already, but it's going to be g of f of x, right? So now that's how simple it is, right? Now, composite functions do not get it mixed up with product rule for the functions, right? Remember how we said that the product rule, right? I'm gonna write this in all red, right? Do not get mixed up with the product rule. So now the main difference that we have here is that in between the f and the g, we see an open circle, right? But then for the product rule that we have, right? The product rule, remember how it was f closed circle g of x, right? In this case, we have an open circle. This is why I emphasized about the closed circle and the open circle, right? In composite functions, there will always be a open circle. But for whatever reason, if there isn't an open circle, then you must only assume that it's the product rule. So make sure that you know that, oh, is it an open circle or is it a closed circle? Because those two are two different things. Even if the product rule might not appear on the Regents examination, but you must remember that, hey, those two are different things, okay? All right, so let's try with some examples here. So, so let's say that f of x, right? Let's say that f of x is equal to the absolute value of x. And g of x is equal to 2x minus 4. Now, find this. Find, or actually solve, right? Find, evaluate. Let's write evaluate. It's a lot easier. Evaluate. Evaluate g of f of x, right? Try evaluating. Well, to 1, because just to make it easier. Try evaluating that. See if you can do it on your own. Remember to write everything out, because once you write everything out, you're gonna see things a lot clearer there. So make sure like there's steps on there, right? And I'm gonna do steps as well, just to show you what the whole type process is. Alright, so hopefully you just pause the video and try to figure this out, right? And let's try to write it inside a different notation form. So this is what I like doing. I like to write it inside a different notation form just so I can understand it. So now this notation, since g is on that, g is first, it's going to be our outer function, right? So g of, and now f is an inner function, right? So we can just write f of 1. Now f of 1 is just equal to the absolute value of 1, right? So that's just equal to 1 since 1 is already positive. So now we have to find g of 1, right? Since we're replacing this. So it becomes g of 1. And g of 1 on this hand is just equal to g of 1 is equal to 2 times 1 minus 4 because of this function up here, right? We already said that g of x equals 2x minus 4, so we just plug in that 1 and solve for it. So, and of course, it's gonna give us 2 times 1 equals 2 minus 4, negative 2. So our answer is negative 2. Now, of course, you can do this with graphs. It works the same way here. So if you, for whatever reason, you have a graph, right, or a map or something like that, it's gonna work the same way. You're gonna have to evaluate for you're gonna have to evaluate for the inner function first, and then you're gonna have to evaluate for the outer function, right? So let's show an example right here for a graph. Let's see how well I can draw this graph. Let's do, we're gonna use blue for f here. So I'm gonna write f of x here, f, right? And we're gonna do red for g. And then g over here. All right, so by taking a look, this 6, we have, this is 2 here, right? And since this is 8, we're gonna put this over here. And this is gonna be, what is it, 2. Okay, so by taking a look at this, right, try to find or evaluate for f of g of 8, right? So remember, we're trying to find the inner function first, and then we find the outer function. So take a moment and pause the video here and see if you can figure this out. Alright, so hopefully you just solved it out and maybe you got the right answer, right? But let's solve this together. So since we want to find f of g of 8, in this case, g of 8 is just equal to 2, right? As we draw up here, we get the y value of 2. So now we can replace it with f of 2 equals what, right? So we're going to f of 2. The x value is 2 over here. And it seems like the value is negative 2. So that means that f of g of 8 is equal to negative 2. That's how simple it is. So now sometimes with these composite functions, right, you have to work from the inside to the outside, right? Most of the time we have to work from inside to outside. In a lot of the next few subjects that you'll be learning, right, you're gonna see a lot of these different types of like problems where you have composite functions, right? So there's also like a little schematic that some people use, right? And that schematic is as shown as here. So let's say if it was like f times g of x, right? And we can draw a little schematic saying like input is x, right? And then it's gonna go down here to this little box, right? To this little box right here. Now the thing is, since our inner function is g, right? So that's going to be related to the input, right? Because x is the closest to g right now. So we're going to label this box as g, right? Now we're going to go downwards to another box, right? Now this other box here, that's going to be the outer, so that's f, right? And of course, over here is going to be our little output, right? And then last but not least, we're going to move down all the way down here to where our final answer is. Now, let me show you this as like a little example, right? So the way how we would do it is like, let's say that f of x is equal to negative 3x plus 10. And then g of x is equal to 2x minus 4, right? So now the thing is, our little input for x, right? Input is equal to x, right? In this case, we're trying to find what is f of g of x, right? So our input's x, right? Which we'll know. And we're gonna label g as like the blue function. We're gonna go downwards to g, right? And since x is just g, right? Well, x is the input for g, so then that just leads us to the original function, which is 2x minus 4. So we're gonna write it here, 2x minus 4. Now we're gonna drag this down onto f, since f is the outer function. And of course, it's gonna shoot out saying that, okay, so the input that we're having for f is 2x minus 4. So we're going to replace 2x minus 4 with the x inside f of x. So then it's just going to be negative 3. Remember the parentheses, 2x minus 4 plus the 10. And of course, our answer as like the result is just going to be 6x, or negative 6x plus 22. And that is our little answer there. So that's how we mainly do these types of problems with using a schematic type. And yeah, while still doing like the schematic type and everything, you can still do it algebraically, right? So you just need to plug inside what the input is and everything else. So why don't we try something that's a little bit more algebraic, just so that you get into the pattern of using algebra to figure out the inputs and outputs. So let's say that f of x is equal to 3x squared plus 2x, and that g of x is equal to 4x. Find g of f of x. Okay, so try to find that out first. Pause the video here, see if you can do it. So hopefully you just figure this out on your own. So now let's try to solve this, right? So since it's asking for g of f of x, right? Why don't we let's just replace f of x by what its original value is, right? So since we know that f of x, I'm gonna highlight this in red. Since we know that f of x is just equal to 3x plus 2, right? We can just plug it in, right? So g, well, this is gonna be equal to g of 3x squared plus 2x, right? And by taking a look at this, right, since we know that g of x is equal to 4x, right, we can actually plug in whatever input that we have into that 4x, right? So that's just going to be 4 times the 3x squared plus 2x. That's mainly how it works. And once, of course, you simplify this, right, by distributing the 4 coefficient to the terms, we get 12x squared plus 8x. And that is our final answer for g of f of x. So it wasn't that bad, right? Of course, do more problems with these, right? Try them out. See if you find it like easier or harder, right? But this is gonna come across a lot on the Regents examinations and any other examinations that they have. So composite function is something that test makers they like to add in there because first of all it confuses whoever the test taker is, and second of all it's where people mess up on a lot. So make sure you practice how to manipulate these functions so that it can withhold like its composite, and then you add all the different rules together. And also, as a final note, do not get this mixed up with the product rule. The product rule is for a closed circle only. Closed circle only. The open circle is for composites. Okay? So that's the only thing that you need to remember, because I barely seen any about the addition rule, the difference rule, the product rule, and the quotient rule. So make sure you guys practice, and I will see you guys in the next video.